Hey everyone, it's Sean. This is Having Fun Repairs, and welcome back to the channel. We're picking back up on part 3 of this restoration series on our Sparton broadcast / shortwave radio model number 6-26. And we've got some fun things in store for this episode. We're going to take care of the speaker, and as a matter of fact, I made a bit of a oopsie. I was holding this and had my fingers wrapped around underneath the cone and put my pinky through the cone right there, so I made it worse. And these things are like wafer thin. But we're going to patch the cone on that speaker using this product right here called KT tape. It's a cotton tape that's very flexible and very light. I started using this after knee surgery, and I had some spare left over, and so I used it on a cone at one point in a previous restoration, and I liked the results from it, so we're going to use it again. We're also going to replace our AC, our line cord, to one that's polarized. Get rid of the old one, and you notice I always get the one with this brown rayon cloth on it. I think it's rayon or something along that. Yeah, rayon, excuse me, not rayon, rayon. I always use that one because I think it always matches very well with the aesthetics of a vintage radio, so I'm going to do that. And then something that I always enjoy doing on these radios is an alignment. So, IF alignments are pretty simple, they're pretty straightforward, but when it comes to actually aligning, our oscillators, any trimmers, and then getting our frequency, whatever frequency we pump into this, to show up exactly wherever the needle's at on the dial, all that kind of stuff I think is very important when you're restoring a radio such as this one. So that is always fun for me. And then we're going to do a bit more tweaking around the chassis per se, getting it cleaned up more. I'd like to get rid of a lot of this yellow tar that's built up, probably. My assumption is, smoker's household, but it could also just be, this radio went into production in 1946. It could be anything at this point, but I'd like to get all that cleaned up. I want to get this glass a little bit more cleaned up. We're going to replace the rubber bushings on the glass as well. I also need to tighten up our dial cord. It does slip a little bit when moving left to right, and it's just gotten old over some time, and you can see there's not a whole lot of stress on that spring down there. So if we shorten the cord up just a little bit, we'll get a little more stress on that spring, and that will help keep a bit more tension on this, or when we go to turn it left and right. So we're going to get a little more cleaning up done. I'm not sure if we'll have a part 4. Not kind of iffy on how much to fit into these videos, because I've realized when they're super long, it doesn't really pull in the audience. The audience attention span is relatively short. But that being said, let's get to this one. So here we go with the speaker, and again we're going to be patching this with a bit of KT tape. Now, if I were to put my finger underneath the cone and lift up, you can see running through here and all the way to the other side. That's how much I cracked it. As a matter of fact, there's a hole right there as well. And then the original crack is somewhat right there, but up through this way, so a lot smaller. Now, a KT tape, it's designed to be stretched when you use it on, say, your joints or muscles or whatever you have to use it for. If you're recovering from physical therapy, you're supposed to, after you cut a strip a certain length, you're supposed to pull both sides and stretch it out, then apply it to your skin, and then it's supposed to, come back together and help hold everything, all your old bits in place. I'm going to go ahead and just trim off the KT end of it, and I'm not stretching this out when I apply it. I'm getting a rough dimension of how much I need, and I'm just cutting that. So now that I have it cut, all you really have to do is just pull the backing off. Pretty simple. just like that, just like so. And like I said, it's designed to flex, to stretch. You see how stretchy that is? That's awesome stuff in my opinion. But what I'm going to do is I'm just going to kind of start more towards the center and just lay this down. Try to get my finger out from underneath it so I'm not stretching it myself, because when the cone vibrates, that's going to be what ultimately stretches it. And then I'm just going to start forming it to the ridge lines and everything that the shape of the cone. So just like that. Now what I typically like to use after this is a little bit of is it E6000 or B6000, and I'll put a bead around the edges, and that will give it some strength. And it's not a glue that gets so hard when it dries up that it's unusable and make the speaker very tinny sounding, I guess is the word for it. It's used in a lot of electronic devices. Let's see, measuring, like cell phones and stuff like that, to hold the screen in place, but it stays kind of goopy, I guess, if I can use that term. I mean, it does have a cure time, but heat and stuff gets it pliable again. It's kind of like a rubber cement, but it's just a very good product as far as the glue is concerned. So again, I cut everything to shape, and I'm just going to try and get just the center in, get my fingers out. Again, I'm going to form this to the shape of the cone, its ridge lines, everything. And that's really all there is to it. You probably don't even need to use any beaded glue around it. And like I said, I'll eventually grab some and put it around the edge. But this is a very good patch in my opinion, and I like how it sounds once powered up, and you know the cone is vibrating. It doesn't have a tinny sound to it. It still sounds pretty good. Anyways, here's the patch for our speaker. This is good. We'll move on to replacing our AC line cord. Oh, while I'm over here at the speaker, I don't really cover this often in my restoration videos, but yes, I do measure the impedance values between the center tap of our output transformer and then the outer taps for the entire winding. And yeah, I have run into issues. I've shown that at least in the past. I do this with every radio. I go center tap to outer. There we go, 370 something ohms, right? Center tap to outer. What was that? 8K ohms. Oh no, that was outer to outer, is that 8K, and then center tap to the other outer, 460 ohms. So this is telling me that we're not quite center, or maybe there's a tad bit more impedance over time between the center tap to the outer two taps. But the only time there's really an issue is when you don't have any continuity between them. Say center tap to one of the two, or either outer tap. That means that you have a break somewhere within the output transformer. And yes, if say like center tap to one side is good, but center tap to another side is not good, yes, you'll still actually get audio through your speaker, okay? But you know, in a push-pull amp configuration, you really don't want that. It's not good for your vacuum tubes. You need things to function the way that they were designed, so I'll just leave it like that. But yeah, you know, again, that's always something I check, even if I don't record it. That's enough waffling. Let's move on to doing the AC line cord. Now, concerning our AC line cord, I'm going to give you a few notes that I think might be helpful for you, and I'll try to get out of stop casting so much a big shadow over this. Anyways, this is a transformer set, and you know, if I go to power this up, probably should get my rings off. I'm so bad about that thing. Yeah, I'm pretty sure most of y'all caught that in part 2. I had it on while powered up, and you know, the chassis metal exposed. This isn't a live hot chassis at all, so, but still better safe than sorry. Take my rings off. Anyways, this is a transformer set, so that in and of itself is better than the transformerless All-American 5s that I've worked on in the past. You know, it's good to have a transformer set. I'll just put it that way. Now, what would make this set even better, as I replace the line cord, is if I was to put a fuse in line with our, basically where the AC is going to travel down this smaller lead here, whichever one it comes to. I think it's going to be the white tipped one here, but I'll ohm it out so I know which one goes to which prong. But to basically run a fuse to our live wire, and then the other side of our fuse would go to the switch over here. Let me zoom in and turn the light on for you. There we go. So if I was to rock this upwards, you see where this line is terminated to that part of that switch, and then we have the transformer going to the other side of the on-off switch. But you know, from the fuse to there would be in addition something additionally good, and then the neutral side would go to this terminal post, and of course to the other tap from our winding, our primary winding of our transformer. Okay, so that's how that would be the safest thing to do. I don't have a fuse on me or fuse holder in order to do that right now, so eventually I'll come back to it. But for now, and I'll just run it that way. The live wire is going to go to the switch, and the neutral will go to here. Now, if this was a non-transformered set, okay, like your typical All-American 5s typically are, you have to be very careful, because a lot of times the neutral is tied to the on-off switch, and the live goes directly to the circuit. So your cutoff is the on-off, and you've seen me talk about this in the past. Well, you can swap them around, but you got to make sure that anything else that's connected to the on-off and to that neutral side, it's got to follow wherever you put the neutral side to next. Okay, so all those things have to be joined up at the neutral. But because this is a transformer set, it's not such a big deal. We have the primary winding that we're just concerned with, and so we can swap those things around, and that shouldn't be an issue. So what I'm going to do is essentially, let me scoot back this way. So I'm just going to cut this old cable out. Okay, that'll make it easier for desoldering, and you can see that they tied a strain relief into here, so basically just a knot around this cord. All right, now it's all out. I'm going to put a little rubber bushing inside of here, and then I'll feed our new line cord inside that rubber bushing, and then I'll put a little strain relief on the inside, some form of knot, and then we will solder this into place up at the top. So as mentioned, we got a new rubber bushing in here, so we're not fraying our line cord coming in. Put a knot on the back side of it, so that's going to be our strain relief. And then of course the neutral over here, and our hot going to the switch. And yeah, let's get this turned over now. I'll need to plug it in, get it turned on, and we'll start doing our alignments. So it's going to be a tad bit hard to demonstrate the alignment. I'll show you why. Just listen to the speaker as I get my phone closer to the radio. As a matter of fact, that popping sound doesn't disappear until I turn off my display and then instead I get a ticking sound that comes from my phone unless I move it further away. There's also interference coming from all the switch mode power supplies inside of, like the SIG-Gen. See, as I move the antenna closer to it with it being turned on. But I'll walk you through the setup here and the adjustment. Now our modulation, or our source frequency, sorry, let me go back here, 456 kilocycles, and that's pulled directly off of the service data. As a matter of fact, you can see it right there, IFP 456 kilocycles or kilohertz. Okay, and what I like to do is I like to set it to 100 millivolts and then turn mod on, put it on a 1 kHz tone, 90% modulation depth, and so I can hear that 1 kHz tone. Now, ignoring the popping sound, how do I know that that's my tone? Well, if I was to go to mod frequency and change it, say from 1 kHz to 800 hertz, that's my modulated tone. And so what I'm going to actually do is I'm going to turn my volume all the way up and get my phone away from this. And then our alignment is pretty simple for IF. It's an adjustment according to our service information here. IF alignment, 456 kilocycles on broadcast, which we are on our switch. And then we are going to adjust C9 A and B, and then C8 A and B. So C9 and C8, C9 there on the left, C8 on the right, left, right, our two IF cans right there for adjustment until we get a peak. And how am I going to know what the peak is? Well, I'm going to listen to it. Now, I've got the output of my SIG-Gen kind of passively coupled to the antenna. It's not directly touching any exposed metal. I just have it clipped to the outer shielding per se of this lead right here, and that should provide a strong enough signal to go in. But what I want to honestly do is I want to come out of here, and instead of 100 millivolts, I want to get this to the weakest signal possible. So I need to drop that and still be able to hear that tone I'm generating once I that tone modulated onto that carrier frequency. And then I'm going to adjust and listen for the highest peak, meaning the loudest it is with each one of these cans, or basically capacitors adjusted inside of these cans. So once I'll do that, I'll go counterclockwise until it fades, then I'll turn clockwise till it peaks, and then clockwise some more until it fades, and then I'll back it off counterclockwise until it's at the strongest point. And then I'll do that for all four, and then come back through and do it all again. So when you're doing this adjustment, it is very possible once you start aligning it, and I'll back away a bit, that your modulated tone is going to get very loud. And that's actually a good thing. So when I come back out of mod, you see I'm at 80 millivolts now. I'm going to take that amplitude and I'm going to drop it down even more because I want the weakest signal possible. Let's do 40 millivolts. Let's see. Ignoring that popping, I can still hear that 1 kHz tone, and I'm going to run back through and do all four adjustments again. Okay, so next we need to align our broadcasts on the dial, both 1500 kilocycles and 600 kilocycles. We'll start with the 1500 kilocycles first, and essentially our SIG-Gen is going to be set to 1500 kilohertz, and then our dial needs to be set to 1500 kilohertz. So if this is 14 right there. And 15 would have to be this center one here. Now we might not be exactly on as soon as I turn on my SIG-Gen and modulate a tone at 15, 16 kilohertz. Modulate a 1 kHz tone onto that 1500 kilohertz carrier wave. But we'll soon find out. And then we have to adjust trimmer capacitors C4 and C5, so our oscillator trimmer and our antenna trimmer. When we look up here, it says C3, 4, 5, 6 refers to the trimmers on the right side of the chassis in the bottom view. So that means if I have this chassis turned over, which I currently don't, it's sitting straight up, then we would read 6543. So if this was turned over, this would be 6543, but it's not. So I actually believe I need to reverse these around, and so this is actually 3, 4, 5, 6, and we need to adjust first C4 and C5. So it'll be C4, C5, and when you look in there, you can actually see the trimmer caps. Let's see if I can get a light on that. There you go. You see them right in there. And we're going to adjust it to get that C4 and C5 for a peak, just like the IF, the strongest signal possible from our SIG-Gen right there. And once I've got that set up, if I've read this correctly, we'll go back and I'll demonstrate how it happens. So although our IF wasn't too far out of alignment, our 1500 kilohertz is way out of alignment, those trimmer capacitors from the antenna and oscillator. So I've currently got it set up, carrier wave 1500 kilohertz cycles, 1 kHz tone. Modulation depth is 80%, whether it's 80 or 90, that's really up to you. But typically I prefer 90, but whatever. We're supposed to be here, should be 1500 kilocycles, but watch this. It's actually showing up around 1600 kilocycles. So I've got to play with these middle two trimmer caps. I'm going to try to use this alignment tool right here, and maybe I'll counterclockwise both of them a few turns, and then see where we end up on our dial. If it's got us closer, then I know that we're, you know, if it moves from here to here, then I know we're in the right direction, whether we need to go counterclockwise or clockwise. So it's kind of just playing with it a little bit until you can get it, till you know which way is going to get you closer to here, and then peaking it up from there. So as a demonstration, yes, it was counterclockwise. Hopefully you can hear that 1 kHz tone. Now I'm going to go clockwise on this trimmer capacitor right here, and you'll hear that 1 kHz tone fade in and out once I go clockwise, or fade out. Did you hear it disappear? Now I'm going to go clockwise, and you should hear it come back in. Alright, now it's back in. Now I'm going to keep going clockwise, and it should fade back out. Now I'll go clockwise, and it should come back in. Alright, and it's very minute adjustments, okay? You essentially just put a little bit of pressure in order to get it to make small adjustments to bring it in and out. And then the same thing will be done for this one. Although I think this one's more the antenna trimmer, so it might actually be 6543, because when I go clockwise I can get it to quiet, but when I go counterclockwise it just continuously stays loud. So what I'll do with this one is I'll need to bump down. See, I'm all the way down to 5 millivolts right now. I'm going to bump that amplitude down to 1 millivolt, which is the lowest I can do. And then I'll come in and out on this one until it's just loud. See, right now I can hardly hear that 1 kHz tone. So somewhere in there is where it just begins to get loud, and that's where I'm going to leave it. Alright, so now we need to do our 600 kilohertz, and we need to adjust oscillator pad, that adjustable capacitor right there, trimmer cap 3. And so I was wrong, and I'll just go ahead and let you know I adjusted this to figure it out, but it is in this orientation, 6, 5, 4, 3, so that one right there is 3. Okay, so that means that 5, which is our antenna trimmer, was this one right here, as I suspected based upon how I heard the characteristics while doing the adjustment. So again, it's very similar to the last one. SIGGEN set up for 600. Let's go out. 600 kilohertz. I got it on 30 millivolts, 1 kHz tone at 80%. And when we turn up our volume and come down, of course that popping is because of my phone. We can see that we're not quite on 600 on the dial. So what I'll need to do is I'll need to take this to 600 right there on the dial, and then I'll need to adjust this cap, and then I'm going to drop down the amplitude of my carrier frequency here, meaning from 30 all the way down to 5 or 4 or 3 or 2 or 1 millivolt, whatever is allows me to do, and peak up on this to ensure that I'm on 600. Now when I get done with this, I'll need to recheck the 1500 because I suspect there might be a rubber band effect between these two adjustments. So I'll need to verify the 600 stays on 600 after I adjust it, and that 1500 is still at 1500. If not, I have to go through the 1500 alignment again, and then go through the 600 alignment again, and keep doing that until there's no more rubber band effect and they both show up exactly where they're supposed to be at on the glass. So I've done just what I said I was going to do on that 600 kilohertz adjustment, and try to ignore the popping sound that's coming from my cell phone being so close to the radio. Hopefully you can hear that 1 kHz tone when I get quiet, but I'll go on and off frequency, and we should have that 1 kHz tone right here. And we do. Now, like I said, I need to verify that there's no rubber band effect. I'm going to change my frequency from 600 to 1500 kilohertz. I'm going to turn back on mod, and we're going to have to go to the glass and make sure that 1500, that 1 kHz tone, is still showing up here. And yeah, it has had a rubber band effect, and so we're slightly off, so we gotta run through both of these alignments again. Get this more towards center, and I'll do the 1500 alignment, then the 600 alignment all over again until they both have pretty much equaled out, and we got 600 and 1500 exactly where they need to be on the glass. Now with it all said and done, here we go. 1500 kilohertz. Now let's change this. pressed the wrong thing. Hold on a second. 600. There we go. Turn our mod back on. I would say that's pretty close. We were getting a 1 kHz tone right around 600 kilohertz. And as seen, we get 1500. On 1500, we're getting a 1 kHz tone too when we make the change at our SIGGEN. So that's going to do it for the AM band. Now we need to move on to, what do we got to move on to? It's our broadcast band, our shortwave band, which means we need to generate a tone. What is this? 18 megacycles. So that's 18 megahertz. And we have 3 adjustments and some dots. Rock dial while making this adjustment. Okay. Let's see. C6, peak accuracy. C7, which is on the underside of our chassis. That's going to be pretty hard for me to demonstrate. And then C23, our oscillator pad, C operation number 7, which is a note somewhere on here, I believe. But yeah, let me play around with this for a bit, and I'll come back and tell you what I've discovered. Okay, so now that I've got a slightly better understanding, that C operation number 7, that's the note right underneath it. Oscillator pattern C23 is precision set at the factory and should not be readjusted out in the field. I've yet to determine exactly where C23 is at least on this diagram. I'd have to look on a different one. So I'm going to ignore that for now and just do C6 and C7, which I honestly have done. So I want to show you how to go about this, so at least how I'm going about this. Now, it tells you that we are going to connect our signal generator directly up to the A on the antenna strip. So I don't have it passively coupled this go around. You can see right here that it is attached to basically the antenna connector, that actual screw right there on our antenna strip. Okay. And again, I've got my SIGGEN set up for 18 megahertz, currently at 10 millivolts, 1 kHz tone, 80% depth of modulation. And I'll turn the volume up just a wee bit. We don't get as much interference like we do on AM that we do on shortwave. So this is a little bit easier to demonstrate. So I'm going to go here to C6 and we'll get in the tone right when I start turning this a bit counterclockwise. Did you hear that? Let me turn up the volume more. You hear it disappear? Hear it come in and disappear again, and as you can see, now this isn't an adjustment, this is just me repositioning the tuning wand. But when I start turning it, you can see it's not that much of a turn. So that's our 1800, and then C7, which is down below. And so now I'm going to take our amplitude and drop it down more. And I'm going to go through this process again. Hopefully I can get it to drop down to 1, but we'll see, hopefully here in a minute, how much attenuation I can give of the signal without completely losing it while making this adjustment on the radio. So about 2 millivolts is where I can get it to. If I drop it to 1, I completely lose it. But yeah, I've got a 1 kHz tone on 2 millivolt. And then it says we need to check our 18, 11, and 6 megacycles. So here's how I'm going to do that. I'm currently on 18, and I can hear that 1 kHz tone. But for this check, I'm going to turn up our amplitude a wee bit. So let me turn down the volume for a second. I'm going to come over here. I'm going to set our amplitude up to, let's do about 20. That's a nice, decently strong signal. So that's 18. Let me go back and we'll set our frequency to 10 megahertz. Mod back on. See if we get that. And we do. I mean, it's not perfect, but it's pretty close. Now there's only one adjustment for shortwave, so close is going to have to cut this. Now I probably could play with it a little bit more on the 18 and maybe get it closer, but I think that's going to be close enough. Let's change it to 6 megahertz. Here is 6 megahertz. Turn mod back on. And it's dead here. Oh, no, take it back. Yeah, it's even a little more below. So I'll probably go back through and play with the 18 one more time and see if I can't get it just a wee bit closer, but if I can't, this is going to have to be good enough. Unfortunately, this is about as close as I'm going to get it, but 10 is almost spot on, and of course 18 is on 18. Looking over the diagram a little bit more, C23 is actually right here. And if you're looking at L5 and C6, well, I mean, C6 is a part of our IF can. You can see that there. Oh no, C6 is on the side, so C23, that pattern, must be pretty close to C6. I'm going to look underneath just to see if I can see it for 1 second. Okay, so the only thing I could see coming off of C6, which is where you see that green wire running to right there. So the little leg comes off and circles over to that mica block you're seeing right there. So I see why it says it's factory set. Maybe it's that little one underneath it, but I believe that to be it. could be mistaken. I see another line coming. Oh, if you'll focus. Realize this is a very poor shot. Yeah, I'm not seeing anything truly to adjust there without turning the radio over and taking a better look. So we're going to call that as good as it's going to get. Okay, I believe I understand better now what is calling that pattern. So over here is C6. That's that trimmer capacitor you see right there. Now if I go over to my diagram, that's feeding on one side of this coil and the other side is C23. Remember me talking about that gimmick capacitor? I'm willing to believe that this is that gimmick capacitor that it's talking about. That's probably the pattern. Because if we follow that line off, that's going to one side of this coil. The other side is feeding to this top part. And then we see that that gimmick capacitor is coming through here. Now it is looping through where this is coming off of C7. But yeah, that's probably why it says it's factory set and cannot be adjusted out in the field. Now, if anybody knows any differently and wants to leave comments in the comment section, by all means do. But I'm pretty sure this little gimmick capacitor right here is what they're calling C27. So we have done essentially all we can do as far as the alignment on this thing. So now I'm going to move into, you know, cleaning up this radio a bit more and getting it pretty. Well, she absolutely cleaned up pretty nicely. A lot of Brasso, a lot of Q-tips, a lot of bit of sanding as well. I went back actually and outlined this KT tape with a bit of that B7000. What is it actually? Got it in here. Yeah, B7000. Oh, welcome to my new lab. Fully moved in and we're set up now. So I mean, obviously I need to clean up my mess from all the work, but yeah, we're fully set up now in the lab. But yeah, I got it cleaned up, and I know that seems to be kind of a touchy subject with some people for some reason, because I mentioned, you know, my customers cleaning the chassis, and I consider that having pride in my work. And my customers actually know the quality of work I do, and they appreciate that kind of stuff. But for some reason that seems to be a taboo subject for some people, because they don't think it's necessary to just repair it and throw it in the chassis, because I throw it in the console because nobody's ever going to see it. But that's not how I do things here, and although I can understand that opinion, that's really all it is, just as mine is my opinion, which is why I like going through and tidying up and cleaning some things up. You see it polished up pretty well. Took the glass off and cleaned it up. Replaced our, here, let me zoom in. Replaced our rubber grommets on here as well. So all that is cleaned up. And I would be actually playing this for you right now, but I had this going in my office when we first moved into our house, and was playing the radio, and then it started to get very weak, and I had to wrap a bit on one of these IF cans, or maybe that tube there or something like that, and eventually it just faded out. The signal got too weak, and I tried to do an alignment again, and I basically have to scream into it from my SIG-gen over there to get an alignment done. So we've got a failure, and it's either in my IF cans or it's in one of the vacuum tubes. I don't know which yet though. But this is where I'm unfortunately going to have to close out this video. We went through all the alignment. We did have a very much aligned radio, and even though I didn't record using it, because I planned on doing that right at this point, showing you all the stations and stuff, We've still got more work to do, to say the least. We've got a failure that now I need to troubleshoot, and it's good I have that plane, so that way it could have that failure, so that way I can figure out what's going on. Because there are some things that I need to address. I did notice a bit of frequency drifting when I was listening to the radio and having to come back and move it around. I don't know if it was because the radio was just, things were warming up inside the chassis, and that was causing maybe some capacitors to drift, to move out of tolerance or something like that, causing an alignment shift. Or if, a vacuum tube, or, like I said, some other things have gone wrong. Additionally, when I, switch between shortwave to broadcast, I don't know if you noticed that in the previous video. It's not, when I do it one direction, it doesn't come through. I have to kind of jostle it to get it to come in. So we need to clean up this contact here. So I think in the next video, I'm going to be, I'll have to recheck our vacuum tubes. We're most likely going to be addressing our switch here, going between broadcast and shortwave. We may be taking apart our IF cans and seeing if there's any issues in there, barring no issues with the vacuum tube. I did notice that my push-pull amplifiers, one of them is getting a lot hotter than the other one, so I'm wondering if one has gone bad, but who really knows at this point? And I'm rambling. But anyways, if you've enjoyed this series so far, stay tuned for the next video within this series. And come back to this channel for more repairs. I've actually got quite a few things, customer repairs coming up, along with finishing the restoration on this Sparton radio for y'all to come back and watch and check out. Anyways, thank you for watching. Please consider subscribing. Give this video a thumbs up. Leave me comments in the doobly-doo. I try to answer all my comments in the comment section. And take care and goodbye. Bark.